So here I am on a Friday afternoon in Budapest, Hungary, my first trip to Budapest on a beautiful mid-September day. It's getting a little bit cool with Stephen Mojzsis. Did I do justice to your pronunciation, Stephen?
That would be just fine.
And you are first and foremost a geologist. You're passionate about geology
right.
from the number of fascinating rock and sedimentary rock samples in your office. But you also, you're also somewhat of an astrobiologist, a geochemist, even a geoastronomer, I would say.
Yes.
And you are professor of geology at the Hungarian Institute of Sciences. Is that correct? Did I get that wrong?
That's fine.
At Konkoly, Konkoly Observatory, which is spelled, it's pronounced differently than it's spelled. But we've been discussing a profound topic, which
Yes, we have.
which no one has which no one really has an answer to. But if there were anyone on Earth who could give very informed answers on this question, how did life start on our planet? The very first life, and when did it start? And you make the argument that it was really the onset of information which spurred life on Earth. Tell us what you mean by that. Give us some context.
Well, let's think about what life is. If life is a chemical system that can evolve and make copies of itself and interact with its surroundings, what instructs life to do that? So inheritance is really information. So all living things have an ancestor-descendant relationship. And so what I like to ask is, where could the information have come from that got that process started? And in my mind, the most logical answer to that problem is that it came from the rocks and minerals that compose the platform of the planet, the crust between or beneath our feet.
And you said it came from symmetry breaking. In other
So
words,
that's what information is.
information is symmetry breaking.
It is.
Explain what you mean by symmetry breaking.
So, imagine that you have information in the form of black and white playing cards, and you had a deck of such cards. And when you pulled the cards, it was black, white, black, white, black, white, black, white, black, white. Just basically on, off, on, off, on, off, 1, 0, 1, 0, 1, 0. There's no information in there. It's just repetition. Going forward and back is exactly the same. What would make it different is if you pull a card that's a different color. Black, white, red. White, black, white, red, black, white, blue, black, white, red, black. Now you're starting to break the symmetry of just 1, 2, 1, 2, on, off, and adding an extra amount of information in there. And for life, that's important because it's what provides instruction.
And so you were telling me that our Earth, the proto-Earth, before
Yes.
the moon-forming impact,
Yes.
within 200 million years of Earth's formation.
Yes.
And this is, by your standards, a conservative estimate. It could have
It
formed
is.
even earlier. You think there could have been some form of anaerobic life here?
There is nothing that prevents the kind of chemistry to have occurred at that time, leading to the origin of life. There is no thermal, physical, or chemical barrier to getting life started about 200 million years after the formation of the planet. That sounds like a long period of time, but it's very, very, very early in the history of our solar system. It's at a time in our solar system where comets and asteroids were still smashing into the planets. The young sun shone dimly in the sky, and our own planet was shrouded in a fluid envelope of gas and liquid water.
And in this onset of of symmetry breaking and the onset of information,
Yes.
how did we actually go from mineral enrichment on a platform of sedimentary rocks, perhaps,
Mhm.
to prebiotic chemistry to actual life? What was the catalyst for that?
Well, we do not know. I mean, the origin of life is one of the greatest mysteries of science. Like, for instance, what is gravity? We can describe its properties, but we can't tell you where gravity comes from or how it operates. The origin of life is really probably a problem of interfaces. The interface between the geosphere, the rocks that compose the planet, and the atmosphere and the hydrosphere, the gas and fluid that interact with that geosphere. That interface is extremely reactive, even today when we see it in weathering, denudation, and erosion, and chemical reactions at the surface. At the time that life got started, those chemical reactions included formation of organic molecules. Organic molecules brought into concentration at such a planetary scale chemical interface probably led to the first biological entities. How that happens, though, requires us to do a lot more work to try to understand it.
And you think that the first life incorporated RNA, an
Well,
RNA world?
Well, RNA is a good candidate for the first life. because
Ribonucleic acid? Is that,
Ribonucleic acid, it is a molecule that is relatively simple. There are pathways to make it naturally without activity of life. And it's a molecule that has the ability to catalyze its own reproduction. It contains information, so it satisfies many of the requirements that we think are necessary to define what life is. So at some point in Earth's earliest biological history, one of the beginning steps was an RNA world before the contemporary DNA, deoxyribonucleic acid, and protein world emerged.
but RNA broke the symmetry, and it and the onset of the and initiated the onset of information. Correct?
Well, something probably from interaction with mineral surfaces which contain symmetrical elements imparted some primitive information to the building blocks of RNA. But how that goes from basically random information, gibberish, to something that encodes and gives instructions for reproduction is so far a mystery to us.
And you told me one last thing that I found fascinating, that you said don't confuse habitability with the ubiquity of life.
Yes, habitability is a concept that the environment is suitable for life to live there. But that does not necessarily mean that life is there. Imagine a stage set where everything is ready to go except the actors are not present. Habitability is a vague concept, and it becomes especially so in the absence of a coherent theory for the origin of life itself.
And so the Miller-Urey experiment was interesting, but did not create life. There are people who are looking to create artificial life.
Yes.
So if you were a betting man, will we understand, will we be able to create life here on Earth artificially within 50 years, 100 years? Is that possible even?
I'd say that it's possible. I'd say that we'd only be able to do it if we could integrate three what are now separate fields of study into one. Information from an RNA world type system, chemical system, encapsulation in a protocellular bag or membrane, and metabolism, the energy that drives chemical reactions forward and allows living things to function. Putting those three together, it may be possible to create life in the laboratory from scratch, from naturally occurring molecules. However, and this is a big however, even if we manage to do that, it doesn't necessarily mean that that's how life started on our planet. So it's more like a metaphor than really an answer.
And this question is arguably not even answerable, is it? How life started on Earth?
I don't think it is until we find life elsewhere. Once we do that, then we can compare the biochemistries for what we have here with what they have over there, so that we have a better understanding of the parameter space of the chemistry going into making functional biological entities.
So, Stephen, thank you so much for being so generous with your time. Fascinating subject and in a fascinating location. Thank you so much for talking to us.
My pleasure.